Hello. In this video, we'll be talking about the 7.2 slope fields notes. The learning objective for today is you'll be able to use slope fields to estimate solutions to differential equations. So let's kind of go back to what we talked about in the previous video about what a solution to a differential equation is. A solution to a differential equation is a function that satisfies the differential equation, so that when you find the function and plug it and its derivatives into the differential equation, it must satisfy the differential equation. Okay. So the beginning says consider the differential equation dy over dx equals x plus y. And here dy over dx is saying the derivative of the function y in terms of x. So in other words, we're saying that y is a function of x. Okay. So if we evaluate this equation, this differential equation, at some point x comma y, we'll get the slope of the solution curve, y equals f of x plus c. Okay. So here, what they give us right here is the general solution. Y is isolated, and there's some constant c present. We don't know what that c value is, so that's why it's called the general solution, because all of the solutions to the differential equation have the same form, f of x plus some constant c. Okay. Based on what we talked about earlier this year and what it says right here, dy over dx is the derivative or the slope of the curve. Okay. So if we evaluate this equation at a point x comma y, we'll get the slope of the solution curve. Before we go any further, I do also want to mention a solution curve. In general, solution curves, multiple, this is the family of functions or the family of solutions to the differential equation. And more specifically, a solution curve is the graphical representation of the family of curves that satisfies the differential equation. And it's curves because, just like we talked about here, the general solution is when there's some constant c present, but we don't know what that constant is. So the solution curves are the family of solutions to the differential equation, and there's one curve for each value assigned to the arbitrary constant c, to the arbitrary constant c. Okay, so now going back, where they give us different x and y values that we can use to plug into the differential equation to see what the slope is at these points. So at the point 1, 1, the slope of the curve is 2. At the point 1, 2, the slope is 3. At the point 1, 3, the slope is 4. And at the point 1, 4, the slope is 5. So we know that the slope of the curve, even if we don't know the equation of the curve. How is this useful? How is this information useful? So even though we don't know the exact equation of the original curve, the solution, because we know the slope of the curve at different points, 1, 1, 1, 2, and so forth, this allows us allows us to draw the general shape of the solution curve. Scooting down. A slope field is a visual representation of all of the possible solutions to a given differential equation. The slopes point in the direction of the solution curve. So if we know at least one point on the solution curve, y equals f of x, we can sketch its graph. So if we look at this visual, this graph to the left, each of these little line segments is showing what the slope of the original function is at different points. So it's giving us all the possible solutions to this differential equation, the same one that was up here. Y prime, again, we can think of as dy over dx equals x plus y. So let's kind of think about how they created the slope field using what they told us up here. At the point 1, 1, the slope was 2. So if we go to the point 1, 1, the slope of that little line segment that I just highlighted is 2. At the point 1, 2, the slope is 3. 1, 2, the slope is 3. Notice how it's a little more steep than the previous one. The slope here was 2 and the slope here was 3, so it's getting a little more steep in the positive direction. 1, 3, it's even a little steeper at 1 because the slope is 4, and at 1, 4, the slope is 5, so it's even a little steeper. Okay. All right, so we're going to practice drawing our own slope field. It says sketch a slope field for the differential equation dy over dx equals x minus 1. We're going to do this first, and then we'll sketch the solution curve. So first we need to figure out what the slope is at some points. So you don't have to write this out every time, but we'll do the first couple like this. If we choose any point, maybe at the point 0, 0, notice that this differential equation is really only going to be affected by x. So it doesn't matter what the y value is. The slope at that point at every, or I should say, the slope at 1, 0 is going to be the same as the slope at 1, 1, at 1, 2, at 1, 3, because this differential equation is only affected by the x coordinate. Okay, so at 0, 0, if we plug 0